Clyde and Jan, thank you very much for joining us on AU Manufacturing Conversations. It's a pleasure to have you both on the program.
Hey,
so let's get going in the standard way, and that is with me asking the guests, how did you get here and what do you make?
Sure. Jan, do you want to start?
Certainly. Look, the reason why we're here is because we are facing a cataclysm. There are so many crises at the moment, all of which focus around the cost of housing, not just the financial cost, but also the environmental cost. And several years ago, I was struggling with my own architectural problems around these sorts of issues. And I realized that we need to start really thinking about things very differently. And I thought about it for like 3 or 4 years, and suddenly I had a eureka and realized that we need to have a continuously operative machine that could produce something that was zero carbon so that we could produce houses without an environmental footprint and equally without much cost.
And similar to that on my journey, it's been about this belief that we could be doing a lot more with robotic systems. And I've been learning to develop robotic systems over the last sort of 15 years of life, and really just come to the same narrative that we've always wanted with robotic systems, which is out of labor. We want them to make our lives easier. And so whilst Jan was having his own epiphanies about construction and architecture, I was looking at productivity and labor, both which have sort of crises across the globe, and saying, well, how do we develop robotic systems that can address those crises? And Project Charlotte, which is the partnership and collaboration between Earthbuilt and Crest, brings together both those stories. And so it solves both those issues simultaneously.
We'll get on to Charlotte, of course, because that's highly topical and highly interesting, and based on the coverage I've seen, highly sexy as far as news stories about robots go. Let's, before that, just give me a little bit of a sort of a, I guess, elevator pitch, if you have one for each of your companies, just so people can have an idea of, outside of Charlotte, what you do on a day-to-day basis.
Sure. We'll tag team it, Jan. So what Crest does is design tools and assistance for blue-collar workers to help them be safer and more productive in their work. And Project Charlotte is all about taking the heavy lifting out of building construction. So it does a specific part of building construction, which is, of course, the walls. And what it does is it's a large robot that moves around a very specialized extruder from Earthbuilt to build sustainably. So, Jan, I'll hand it over to you.
I wish I could say that I'm doing anything other than Earthbuilt at the moment, which is just a startup. When I started this, I had a perfectly good architecture practice, which has just gone so badly to seed. It needs my attention. But what I discovered when I got on this Earthbuilt journey was that it was bigger than I am and far more important. The construction industry consumes between 20 and 30% of our carbon footprint in the world, and around, if I'm correct, 15% of our global GDP. It's a behemoth and it's heading in the wrong direction. And when I realized that I had in my hands the technology to turn that around, I put down tools and made that my only focus. So other customers, you got to be joking. There are some out there, and if they're lucky enough to have my attention, then that's awesome. But my architectural practice is totally secondary to this one.
Let's look at how you both came together on this project. What's the thing that linked you up?
So we've both been on a startup journey over the same period of time, and we're both in what's called a hard tech space. And you guys are all manufacturing people, you know what that means. And so we met on a introductory weekend at a place called The Melt in Muswellbrook, where we met up with a whole bunch of other really interesting startup founders, and we got talking. And I'd been thinking about using a robot instead of gantry systems and instead of crane systems as our 3D printing vehicle. But I'm not a robotics engineer, and I really don't know what I'm doing in that space. And I met Clyde, and he's a very impressive guy. And he was working in not just robotics, but in a very appropriate space, because he's talking about having robotics to replace people in dangerous workplaces like construction zones. And so we got talking, and we decided to try something together.
Right. I think Clyde might, and I don't want to ever pretend to be speaking for someone, but based on the material I have read of his company, I think you'd probably say augment rather than replace workers.
Yeah, that's right. That's right. We're not naive enough at Crest to think we can replace people entirely. What it's all about is developing tools to enhance and supplement. So, fundamentally, we see the market as the tradespeople currently in the industry that would adopt these tools, whether it be Charlotte, Emu, Gorilla, or any of the other animal robots that I'm bringing to market. It's about taking the danger out of the job and not the person.
So, which means that in some cases it is taking people out, like on the moon, for example. This technology that we've created, Charlotte, is very agnostic about what planet it's used on. It can be used on Earth, but it can also be used on the moon. The moon is a very dangerous workplace, and it's best that astronauts aren't putting on their gumboots.
So let's contextualize Charlotte a bit. What does she or it, I'm not sure if you gender the robot, it's not my business, but Charlotte, let's talk about it, her, them, I'm not sure. What does it look like? What are its features? What are some of the subsystems, components, blah, blah, blah?
Sure. I guess I'll talk about this, Charlotte, if you don't mind.
Yeah, definitely.
So Charlotte is a large six-legged robot. We often call a six-legged robot a hexapod. It's designed to 6 legs a construction site, and especially the walls of a construction site as it 3D prints them. So unlike most 3D printers that have to be bigger than the houses they built, Charlotte's capable of just straddling the walls and stepping over walls as it essentially 3D prints the structures. So critical components are, of course, the robot and the extruder. But the extruder also gets paired with a very sophisticated fill delivery system that transfers over material at really highly productive rates. And that's how the actual material gets to the robot. So those are the major components of the system. I don't want to go into a lecture about what goes into a robotic system, so I'm gonna call a robotic component. Same with the extruder, same with the fill systems. They're obviously made up of a lot of really interesting IP and a lot of underlying pieces and elements. But those are the major things. So Jan might talk to you about how we can source material. I think could be really interesting.
Yeah, so if you have a look at the Earthbuilt extruder itself, so this is at the very center, literally at the center of the Charlotte robot, is a print head. And that print head is a 3D printer. It's much like many other 3D printers in many respects, except that it uses an entirely new structural mechanism. Instead of using a cement or a glue or heat to create coherence and bind the layer that it extrudes, it wraps it. It wraps it in a continual membrane or fibrous weaving. We've got a couple of variations there in R&D. And by doing that, it takes the material, which is a particulate fill, like earth or like crushed building materials or like regolith on the moon. It takes that and it compresses it as far as it will go into a solid mass, very much like a brick, but a continual one. But instead of firing it, instead of gluing it, it wraps it on the outside edge. And if any structural engineers are listening there, they go, oh, that's kind of clever, because that's the one place where tensile membranes are really useful, just to hold the material together. As long as that material on the inside is held together, it will remain structural. It's a kind of system that was invented in France in 1963, but mostly only ever used in highway design as a material called terre or reinforced earth.
So it's like a little sausage skin with some dirt in it, tamped down nice and tight.
Yeah, but we don't use the word dirt because that implies dirty. It's filthy.
As I mentioned earlier, you got quite a bit of coverage from the ABC and other publications. What do you think is behind the, I guess, popularity or interest in what you're doing? Why do you imagine people seem to care so much?
It's because people need to live in houses. It's a basic human need. And houses are becoming less and less affordable. And even if people can afford to live in a house, which they should be allowed to, people are becoming more concerned about the footprint of those houses in terms of the carbon footprint. A house can measure tens of tons of carbon footprint. A double brick one is enormous. And so anyone who's looking at building a house, they're looking at their budgets first and foremost, but they're also looking at their impact. They want to have a place that their grandchildren can still be happy and not subject to cataclysm. So there's a couple of major points. Also, and this is a very important one, Charlotte's designed to be fast. It's designed to build really quickly. And the bottlenecks in construction, they don't just slow down the construction, which is bad enough. They also increase the costs very significantly. If you have a look at just the costs of laying brickwork for a house, you might be talking between $30,000 to $60,000 only, which ain't a lot. But once you consider that that's the major bottleneck in the building process, you actually see how it can expand very quickly to $200,000 or $300,000 because everything else is slowed down.
There are some other companies that are focused on similar problems to you, namely the bottlenecks in construction and the lack of affordability and availability and labor issues and the rest of it. Some of them we've had on our podcast before, such as Luyten and FBR we've been watching for a while. And I wanted to know if any of those guys had inspired you or perhaps given you a few tips here and there on how to go about what you're doing.
We want to cooperate with those guys. This is a huge market opportunity, and we're not interested in fighting on the outset. We're on the same team. We're willing to work with those people collaboratively and productively. But that's not the only point. The main point to add here is that our supply chains are shorter than any other supply chains, as short as possible. We take raw materials and we turn them into walls without any prior processes. We don't require cement to be made. We don't require it to be shipped to site. We can use earth from site. We can use local construction waste. We can use whatever's there because our robot is very agnostic about what goes in. So with these very short supply lines, you can be guaranteed that our robot is going to be able to produce quickly and efficiently without any delays. But when we're talking about delays, our robot can literally arrive in the back of a truck and step off the truck itself, get to work, do the work, and climb back on the truck so you don't have any setup time or completion time. Nobody can do that. We're the fastest, no question of it. And our print head is huge. Our print head is 30 centimeters wide and 7 centimeters high. That means that with one run, we're doing more than any other 3D printer.
It's fundamentally, it's a very different approach. So shout out to Mark and Ahmed. I've actually met the founder of Luyten just last weekend. Really lovely bloke. And Mark from FBR has been at it for, they've been at it for 20 years now, and they're making some real strides. And so it's really good to look and see these companies that have built their technology in Australia and started to implement it in Australia. That certainly gives us a lot of confidence that this sort of work can be done here and should be done here because they've really laid down, framework and pathways over the last 20 years to give others a go, which I think is really, really important, really impressive. From my perspective, the housing crisis needs to be solved with lots of technologies. And it's really important that all these companies come together with different approaches that are all suitable and usable in different ways. But it's about enabling our builders and our construction companies with new and advanced technologies to give them options for how they want to choose to go ahead and build houses faster and safer and more cost competitively, hopefully, for the Australian consumer.
Earlier, the topic of the moon and how inhospitable it is for human workers and probably everything else that's there. Tell me about how some of the challenges of the lunar environment are informing what you're doing with this robot.
The moon is probably the most dangerous place almost in the solar system. It's actually harder than some other rocky planets to operate on. And it represents the most pressing need for high sustainability products and construction methods. And that's because it's extremely difficult to take anything with you at all. So every process when it comes to using materials or consumables needs to be truly circular on the moon. There's nowhere to put waste. There's nowhere to pick up new supplies. And so developing technology for this truly extreme environment actually makes the process of doing so on Earth a lot more easy. And so it's really important that we absolutely nail these technologies in these environments and bring that technology back to Earth where it can be most impactful.
And would you be able to talk about how sort of technologically mature Charlotte is? Is it some way off from being used in the real world or real off-world scenario? What can you say about that?
Charlotte represents several technologies that are coming together. Most of those technologies are at what's called TRL level 5. We've tested them. We know that they're working. We still need to integrate them properly. We still need to test them in their final integrated state. And so there's still work to be done, which is one of the real reasons why we're reaching out to people like Luyten, because they've got technologies that are much more advanced than we do, and we can work with them.
And just a couple more questions before I leave you guys alone. Are there any other notable projects that you're involved with at the moment that you'd like to tell us about?
Sure. I'll give a couple. We got fingers in a lot of pies at the moment. And so we just had our first second trials down in the energy infrastructure sector where Zinfra have trialed one of our products called the Gorilla Mark 1 Robotic Puller. And that's helping ease the burden for line workers doing energy transmission line maintenance. So it's essentially a tool that drives along power transmission lines and deploys devices useful in maintenance operations. And we just had some really good successful trials down in Victoria. We're also beginning on a new pathway for a new product to market we call the EMU. Now what the EMU does is it's supposed to solve repetitive overhead work. So working in heights is what we're aiming for. So we're talking to a lot of big construction companies and partners, but we're always looking to talk to more that are interested in a trial. And it's essentially just a very large form factor robot arm that's extremely light. So the first product version of it we're building is 3.7 meters tall, but the whole robot will only weigh less than 60 kilos. So it's extremely light, extremely fast. We'll equip it with any tool, and its goal is to do repetitive overhead work. So that could be anything from overhead drilling to pressure washing, laser cleaning, using a nail gun. Really, anywhere workers are getting up on step ladders, which is one of the riskiest things we see on work sites because there's no safety on a step ladder. You just fall, and doing some of that really repetitive work. So we're always looking for more partners that have new applications for that as well.
And our Earthbuilt printhead isn't just designed to work in Charlotte either. We can stick it on any other 3D printing vehicle, and we can even stick it on the end of an excavator or back of a tractor. A little while ago, I was thinking about getting a ute and digging a hole in the back of my ute and using that just to drive along, making a wall just to show that we can. So there's some other ways that we can do this other than using sophisticated robotics.
And so the closing question, as with other interviews, is this one. What's an issue within manufacturing that isn't getting the attention it deserves in your point of view?
I wouldn't say the valley of death. When you're doing a hard tech startup in Australia, it is not a great environment for it. There's very little appetite for risk in the investment community here, and they see everything as risk. They don't see the rewards, they see the risk, and there's very little government support until you really get a move on and start clicking through those TRL levels. And if there is government support, you have to support it with equivalent investment, and that's often impossible to get.
As far as manufacturing goes, I just wish there were more of it. If you're a manufacturing partner, please reach out. We do try to keep things local where we're able to, where it's cost competitive and where, we really need locals to talk to get some of our parts made. So we get parts made all over the world. We get a mixture of parts coming from overseas and parts coming from here in Australia where we can manage it. And so the difficulty is for some types of parts, say bent tubes, for example, bent fabricated tubes, it's hard to, especially at the sizes we're looking for. There's quite a lot of people out there that do architectural and building size things. But when you get down to sort of making machines and robotics, it becomes pretty slim pickings in terms of who you can actually go to manufacture something locally. That's the main manufacturing hang up, to be frank. The size and type of machines we're building, there's not a big industry here in Australia for it. And so that's the hardest part when it comes to building them.
Okay, guys. Well, I appreciate you've got stuff to do. And so I'll thank you for your generosity with your time and wish you a good day. Thank you for being on AU Manufacturing Conversations.
Thanks, Brent.
No dramas. Thanks, Brent. Lovely to be here. And thanks for your time.